So the last part of chapter 4 talks about energy. And as you guys probably all know, we classify energy in two ways. It's either potential energy or kinetic energy. Potential energy is energy that's due to the composition or position of something. So if we were in the classroom right now, I would take the big chemistry book or a big book of some kind, and I would ask you if it had energy as it was on the edge of my desk, and you would probably say yes, because I could drop it. So then I would drop it, and it would make a large noise, and I'd say, is there any potential energy left in the book? And most of you would say no, but somebody would say, well, we could still get more energy out of it. And I would ask you how, and you could say, well, we could burn the book. And sure enough, that would give you energy in the form of heat. So we have potential energy versus because of composition or because of the position of the object. And kinetic energy is energy of motion. So we had potential energy changing into kinetic energy as that book fell off the table. Okay, so potential versus kinetic energy, yeah. We're also going to look at energy and reactions. And you've got two options if energy is taking part in a chemical reaction. Energy can be released, or energy can be gained or absorbed. Okay, so energy can do two things. If energy is released, we say that is an exothermic reaction. Exo meaning to the outside. And what that means is the reaction is giving off energy and the potential energy of the system is actually decreasing. I'm running out of space here, so I'm going to write pot E and an arrow down, meaning potential energy is decreasing in an exothermic reaction when energy is being released. On the other hand, if you heat something up, energy is being absorbed by a system or gained. That's called an endothermic reaction. Endo to the inside. So, and with an endothermic reaction, we find that the potential energy is increasing. Okay. You'll do more of that in a thermodynamics chapter later. Your book now talks about the law of conservation of energy, which you ought to know. Energy cannot be created or destroyed in a chemical reaction, only transferred from one form to another. So say with the with the book, we had potential energy in the form of composition, and you burned it. That energy was transferred to heat and basically served to heat the surroundings up, the area around it up. When we measure heat or energy, we use the unit, the joule. This was the SI unit for energy, and I don't know if we talked about this before or not. Okay, that actually says Joule. The abbreviation for joule is a capital J. It used to be a lot easier when we were talking about measuring energy to talk about the calorie, because the calorie made a lot of sense. So let's go back to a calorie and then go to a joule for a minute. Another unit of energy is the calorie. This is a calorie with a lowercase c, and 1 calorie is the amount of energy needed to raise 1 gram of water by 1 degree Celsius. Okay, so I always really liked knowing what a calorie was. That'd be like 1.00 calories, something like that. It turns out that 4.184 joules is equal to 1.00 calories. All right, the joule is the SI unit. It's what we should be using. And you can always turn inequality into a conversion factor. So you do want to remember that you can put 4.184 joules over 1 calorie and the reverse, 1 calorie over 4.184 joules. So to do that, if I was going to do a conversion here, except I don't have it worked out. Okay.